Hey guys, okay, no intro. Let's get right to work. Write in standard form, so we have to expand all of this. Using the word bank, label each polynomial with a word from each row. So we're going to call it something after we expand it. Distribute your x and your negative 2. We'll get f of x equals x squared plus 6x minus 2x minus 6. Combine like terms, x squared plus 4x minus 6. This is 3 terms, so it is a trinomial. And the leading term is a square, so it's a quadratic. We call it a quadratic trinomial. Okay, number 2, you get to FOIL here. Multiply the x with the x squared in the 2, and then multiply the negative 2 with the x squared in the 2. You'll get x cubed plus 2x minus 2x squared minus 4. To write this in standard form, though, you need descending degree. So I need to get the negative 2x squared before the 2x, and you have it like that. This is a cubic because its leading term is a cubic there, or is x cubed, and it has 4 terms. We just call this a 4-term polynomial. After trinomial, you kind of no longer get fancy with the words. Okay, in this one, you have to be careful not to FOIL immediately because that square is there. This is x minus 2 quantity squared. You could write this as x minus 2 times x minus 2 times x plus 1. That tends to help most people. This becomes x squared minus 4x plus 4 times x plus 1. And now we'll go ahead and start doing some distribution from a trinomial to a binomial. I'll take the x squared multiplied by x plus 1, the negative 4x multiplied by x plus 1, and the 4 multiplied by x plus 1. And then we'll combine like terms. First I'll get x cubed plus x squared. And negative 4x squared minus 4x. And then plus 4x plus 1. Let's see what we got here. We got an x cubed. X squared minus 4x squared is negative 3x squared. Negative 4x plus 4x is 0. And then you get, oh, I'm sorry, this isn't plus 1, this is plus 4. And so this is 0, and all that's left is your plus 4 right there. So there's your final answer. And that is, once again, a cubic. You can tell right there. And it's a trinomial. Once again, 3 terms. So you can see the difference between these two cubics. One has 4 terms, the other actually has 3. Okay, number 4 and 5. Find the multiplicities, find the zeros, the x-intercepts, and state the multiplicity. Multiplicity means how many times a certain value appears. Like, for instance, on number 3, that has a multiplicity of 2 right there, because x minus 2 is being multiplied twice. Here it looks like they're all certainly unique, and to find the zeros, or the x-intercepts, it means find the values of x when y, or f of x, equals 0. So use zero product property here. If these 3 are being multiplied together, it equals 0. Either x minus 2 equals 0, x plus 3 equals 0, or x plus, 1 equals 0. So x equals 2, x equals negative 3, and x equals negative 1. Now all 3 of these have a multiplicity of 1 because they're never multiplied more than 1 time. And I'll get what that means on a graph actually after we do function in standard form. I'd prefer to do this first because I want to get the y-intercept as well. And if you remember in standard form, when your y-intercept is when x equals 0. So check out this function right here. If I set x equal to 0, these go away. The value for y is negative 6. If I set x equal to 0 here, the value for y is negative 4. And if I set x equal to 0 here, the value for y is 4. The constant in your standard form is your y-intercept. So that's why it's good for me to get right off the bat. So I'm going to take this function here. I'm going to start distributing x minus 2 times x plus 3. And I'm going to find out what standard form looks like. Okay, so we got x squared plus x minus 6 times x plus 1. That'll give me x cubed plus x squared plus x squared plus x minus 6x minus 6, which is x cubed plus 2x squared minus 5x minus 6. Now the important number that I get out of this when graphing is the negative 6, because that means that the value 0, negative 6 also exists on my graph. So I'm going to go ahead and graph these points here. 2, 2, 3. Okay, so I know that my graph does the following. I know that it crosses through -3, -1, and 2 on the x-intercept, on the x-axis. And on the y-axis, I know it crosses through -6. I also know that my function's positive. Take a look at that. There's a +1 factor outside of all of this, which means it starts from the bottom. As a cubic, its behavior means start from the bottom, finish at the top. Or if it's negative, start at the top, finish at the bottom. So if it starts at the bottom, it's going to end up crossing through here. So pardon probably a poor drawing here. I'm going to go through, up and through, and now it needs to come back down and hit here. Okay, it goes through there. Now somewhere it needs to hit the y-intercept there, and it needs to finish back up. My relative maximum and relative minimum aren't necessarily easily found, and they're not always right in between any set of points. That doesn't mean it has to bounce back right there, but it does mean it has to cross through those points. And obviously, I didn't do a very good job at that, but you can kind of see what happens there. And that's why it's important for it to have that point. And on the very last problem on the back page, you'll see that more. Okay, number 5. I'm going to expand this for a second, just to x plus 1 times x plus 1, so then you truly see what multiplicity of 2 means here. So if we set these equal to 0, that either means x plus 1 equals 0, x plus 1 equals 0, or x minus 3 equals 0. So that means x equals -1, x equals -1, that's a 7, or x equals 3. So you can see x equals -1 appears twice. That gives this a multiplicity of 2 at x equals -1. And then at x equals 3, that's a multiplicity of 1. It only multiplies in there once, not twice like this guy. What that means on a graph, by the way, I'm still going to have to get the other guy, whatchamacallit, the y-intercept. But what that means on a graph is that somewhere it hits -1 and 3 on the x-axis, but because this is still a cubic function, you'll see when I expand this over here in standard form, because it's a cubic function, it's a positive, it still has the behavior of starting from the bottom and finishing at the top. And it can't do that this way without it actually crossing through another point. So it can't cross through the x-axis twice. It can only hit it once, which is what we're going to find out, and it's going to come back and do that. Now, I want to redraw this once I get my x-intercept, my y-intercept, but these will be my x-intercepts. And this feature, bounce back feature, appears because this is x plus 1 quantity squared. At x equals -1, it acts almost like the vertex of a parabola, and it has that bounce back. But let's get the y-intercept first, and then I'll do that. So I'm going to distribute. I'll actually just work from here. This gives me x squared plus 2x plus 1. And this gives me x minus 3. Okay, so x cubed minus 3x squared plus 2x squared minus 6x plus x minus 3. Combine like terms. I get x cubed minus x squared minus 5x minus 3. There's my final answer in standard form, but the most important feature that I really needed was that -3. This is my y-intercept for this graph over here. So now I know where this guy crosses the y-axis when it graphs. So again, it's a positive. That means it starts from the bottom on the left side and it's going to finish at the top. So I'm going to come from here. It's going to bounce back right here. It's going to come down and cross through here. That's its y-intercept. And it's going to end up finally coming back up and finishing through. And voila, there's my cubic. Very, very iffy. But there it is, and there's your answer. Okay, find a possible function that has the following zeros: 2, 0, with a multiplicity of 2, and -3, 0. All that means is that these are your x-intercepts. So you have x equals 2. It says multiplicity of 2. So if you see kind of the problem above, how I listed that twice, it has multiplicity of 2. That's what that means. So let's kind of work backwards. It's almost the exact opposite of this. I have x equals -1 at a multiplicity of 2. So I list it like that. And same thing here. X equals 3 with a multiplicity of 1. That means that your actual factors are x minus 2 equals 0, x minus 2 equals 0, and x plus 3 equals 0. Okay. Which means in factored form, that's x minus 2 times x minus 2 times x plus 3 equals 0. So if you want the actual polynomial, you need to write a y equals, or f of x equals somewhere. And I'm going to combine these into a square. So this is going to say f of x or y, doesn't matter, equals x minus 2 quantity squared times x plus 3. There's my final solution for that. And if you want to double check, you can start from here, work backwards, make sure you get those answers there, just like we did for 4 and 5. Okay, let's do the same thing here. X equals negative 5, x equals 2, and x equals 0. Now remember, when x equals 0, what that means is x minus 0 equals 0, or one of your multiples is just x. Okay, this crosses at the origin. This crosses at the point 0, 0. That's why it's an x-intercept of 0. So x plus 5 equals 0, x minus 2 equals 0, and x equals 0. I like to put this x in front here. This will be x, this guy right here. That means x times x plus 5 times x minus 2 equals 0. Or f of x equals x times x plus 5 times x minus 2. Remember, all that means is these are the values 0, 2, and negative 5 that I can plug into this equation. And no matter what, when they multiply, I would get 0 out for f of x. And that's all. Okay, practice your long division. State whether the divisor is a factor. By that it means remainder of 0. So you have your dividend, this guy that's on the inside right here, private parenthesis right there, and your divisor. Long division, everyone has their different syntax here, so I apologize if mine looks different. Make sure you hear what I say as much as you kind of follow what I do. I'm always looking at the most complex term right here, and I'm always going to compare my a to these guys here. The 9 will follow when I do multiplication. How many times does a go into a cubed? The answer is a squared times. You multiply a by a squared, you get a cubed. Multiply 9 by a squared, you get 9a squared. I'm going to subtract a cubed by a cubed, and I get 0. 12a squared by 9a squared, I get 3a squared. I'm going to compare that, plus 35a. I bring that down. I need as many terms to bring down as I have right here. So I can do proper comparison when I do subtraction. How many times does a go into 3a squared? The answer is 3a times. So a times 3a is 3a squared. And again, this should always cancel out right there. That's the point. We're trying to get rid of some values there. Just like when you do regular long division, we're trying to get rid of one of our places, like hundreds place, tens place, whatever it is, until we break it down to the units place and get rid of that. So that becomes 0, and this becomes 8a. This is plus 72 when I bring this guy down right here. And we're going to compare that to a plus 9 as well. Okay. How many times does a go into 8a? The answer is 8 times. So I multiply a by 8, I get 8a. 9 by 8, and I get 72. Subtract, and you get 0. So the remainder is 0, and this is your final factorization of that guy right there. So the answer is a squared plus 3a plus 8. This is, well, of course, this is a factor. The point is, a plus 9 is a factor because I didn't have a remainder in the end. Okay, did not have a remainder in the end. Okay, let's do long division again here. Now you have to be careful when you do division on this one because it's missing my x cubed. I could rewrite this right here as 3x to the 4th plus 0x cubed minus 2x squared minus 3x plus 1. And I will surely divide that by x minus 1. The reason for the placeholder is so that I know when I combine like terms which ones I'm adding with each other. This is where things get tricky because you have a minus to take care of, and when you subtract negatives, just make sure you stay consistent with what you do. X goes into 3x to the 4th, 3x cubed times x times 3x cubed is 3x to the fourth. Negative 1 times 3x cubed is negative 3x cubed. Subtract. This becomes 0. 0 minus negative 3 is 0 plus 3. So this will be positive 3x cubed. I got to bring down negative 2x squared right there. The reality is you can bring down every single term that you want. It's just none of these are going to compute with anything. That's why I bring them down later. X goes into 3x cubed. 3x squared times. So that'll give me 3x cubed. Negative 1 times negative 3x squared is times positive 3x squared is negative 3x squared. That'll give me 0. And negative 2x squared minus negative 3x squared is a positive x squared. I'll bring down the minus 3x here. Oops. Okay, how many times does x go into x squared? Well, of course, x times. Multiply, you get x squared minus x. This becomes 0. Negative 3x minus negative x is negative 2x. I bring down the plus 1. I get x minus 1. And how many times does x go into negative 2x? Well, negative 2 times. X times negative 2 is negative 2x. Negative 1 times negative 2 is positive 2. And this is 1 minus 2. Be careful. And you get a negative 1. So this is your remainder right here. This negative 1. I'll put a remainder negative 1 there. This is your quotient, your final answer. And the fact that there's a remainder means that x minus 1 does not divide perfectly into this, which means x minus 1 is not the father. It is not a factor. Okay, practice using synthetic division. State whether the divisor is a factor. Same thing, you're just going to see if you have a remainder or not. Now remember the syntax here. V minus 4 means that we're considering V minus 4 equals 0 to be one of your x-intercepts. So that means V equals 4 is one of your zeros. So I'm going to use that and list 4 as my 0 when I do division. So this becomes 5v cubed. What I'm going to do is start listing all of my coefficients of this term in descending order. 5, negative 16, negative 21, and 20. And I'm going to add to how many times my value, technically what you're doing here, because I haven't talked about this too much, synthetic division, you can only use synthetic division if you're looking at linear factors. Okay, so I'm checking to see how many times v goes into 5v cubed, etc. This answer is 5 times, and what happens is this becomes a v squared now. We kind of talked about that. And then you multiply your values and they cancel, etc., etc. Maybe during my actual review I'll spend more time with it. But I'm going to multiply this number by it, and then I do subtraction. In this case, I'm just multiplying this number by it and adding. So 4 times 5 is 20. And you're going to add. Negative 16 plus 20 is 4. Basically, I'm explaining more than what you actually have to do. You're just going to multiply this by here, place it here, that's 16, and then you bring it down. But if you need to truly hear what's going on to say, what's the tie-in between this and long division, I'll get more explanations for my final chapter review. 0 is your remainder, negative 5 is your constant, 4 is your linear term, 5 is your quadratic term, meaning your coefficient. So your final answer here is 5v squared plus 4v minus 5. There's a 0 remainder, so that means that v minus 4 is a factor. Okay, number 11. Same thing. You have to be careful though with the placeholder here. This should have a plus 0x squared in between all of this, and that's super crucial when I do that. Let me list those in a second. As soon as you see what your 0 value here is negative 2. So I'm going to put the negative 2 off in this corner. I'll list 2, negative 3, 0, x is 1, and then negative 5. 2 plus nothing is 2. Negative 2 times 2 is negative 4. Negative 3 plus negative 4 is negative 7. Negative 2 times negative 7 is 14. 0 plus 14 is 14. Hang on. Whoa. Then let's just call this 14. Negative 2 times 14 is negative 28. 1 minus 28 is negative 27. Negative 2 times negative 27 is positive 54. Negative 5 plus 54 is 49. That's a big remainder, but that is your remainder right there. So with that remainder in mind, that's remainder, constant, quadratic, or excuse me, linear, quadratic, cubic. So my final solution will be 2x cubed minus 7x squared plus 14x minus 27, remainder 49. Now, how do remainders work when you actually do factoring? I'll make sure to tell you that in a second. Now, this is not a factor. Now, just because it's not a factor doesn't mean you can't factor out and get a remainder out, and that's the whole point to this. So, what if they ask you to write this polynomial in factored form? What I would say is this. I'm just going to write this on the bottom. I'll say 2x to the fourth, just so you have an idea of exactly what we're doing here, minus 3x cubed plus x minus 5 is equivalent to this. X plus 2 times 2x cubed minus 7x squared plus 14x minus 27 plus 49. That's where that remainder exists. So if I were to factor this, I divide this out and I get this left, but I get that remainder, and again, that's where it fills in at the end. Okay, graph each. Now, I already have these pre-graphed for you. The main reason is so I don't have to spend time drawing it, and because they didn't give me axes, and so then I can talk about where the zeros exist, etc. But these are your final two. What you're going to do here to find out how to graph this is find your zeros for x, and find your y-intercepts if they exist. Well, they all exist, but if it's not, if it's not 0. So here I see a common factor of x. So I'm going to find that. Now remember, this isn't on your screen, or on your page, this is where you'll graph. X squared minus 3x minus 10. Now you have to keep factoring here. If you do the diamond, what two numbers multiply to negative 10, add to negative 3, that's negative 5 and 2. So f of x is x times x minus 5 times x plus 2. And you're good to go there. So what your zeros are, again, you set this equal to 0 if you have to. And you'll get either x equals 0, x minus 5 equals 0, so x equals 5, or x plus 2 equals 0, so x equals negative 2. So what I did, so you can see those numbers there, and then I'll give you a look at this graph. What I did was I went onto the site called graphsketch.com. I just plugged this equation in and had this graph. That's why it looks so perfect and beautiful. And these actually have real numbers where these are crossing through the minimum maximum. You won't always find them for yourself. But what they do show are my three zeros right here. X equals 0, x equals 5, and x equals negative 2. And this is a positive function right here. So that means it starts from the bottom, it comes through, it hits there, crosses right through the origin, which is why you have a y-intercept of 0, by the way. And if you think about it, look back at your standard form, it has a constant of 0 right at the end. Your y-intercept is 0, and you have an x-intercept of 0. And then it goes back down, comes back through, and hits there. This one's a little different, number 13, because there's no common factor of x, because there's a 25 right there. So what you have to do is either learn this thing called rational root theorem, which I don't believe we go over in this class, or you have to be given a 0. It's the only way that you can end up getting to a quadratic, which you can then factor. So what we have to do is divide. If x equals 5, then x minus 5 equals 0. So you can either divide this long division by x minus 5, or you can use the 0 of 5 and still do synthetic division, and then end up getting a value. Get out of my way. So let's go ahead. This is 1x cubed minus 1x squared minus 25x plus 25, and x equals 5 is one of my zeros. So I'll use synthetic division to speed this up, which is okay to do because I have a linear factor. So here we go. Bring down the 1. 5 times 1 is 5. That becomes 4. 5 times 4 is 20. Negative 5 plus 20 is negative 5. 5 times negative 5 is negative 25, and I get 0. That's your remainder, constant value, linear coefficient, quadratic coefficient. So right now, what you're looking at, you have to be careful here. You're not just looking for what the division is. You have to state what g of x is as in factored form, which is exactly why I showed you that this time when I was writing it, how I was factoring that out. But I can continue factoring here because I need to find all of my zeros. So g of x is now x minus 5, see that there, times x squared plus 4x minus 5. So this is the same thing as this. I can keep factoring now. This will be x minus 5. Here, the two numbers that multiply to negative 5 and add to 4 are 5 and negative 1. So that's x plus 5 times x minus 1. And there's your final factored form. So let's go ahead and look at the factored form versus the graph. I should have zeros at, should probably write them up here. I'll have zeros. If x minus 5 equals 0, then x equals 5. We knew that one. If x plus 5 equals 0, x equals negative 5 is a 0. And if x minus 1 equals 0, then x equals 1 is one of my zeros. So you should see your graph cross at negative 5, 1, and positive 5. So you see it hit those points. You see that this is a positive cubic function, so it starts from the bottom, hits through there, etc. No multiplicities. And the third thing that you might find is this 25. And that 25 is your y-intercept, which means your graph crosses through your y value at 25. Not that it necessarily has a relative maximum there, but it definitely hits through there at that point. Okay, so that ends up being your final graph, and you do your sketches you need to, but make sure you at least label that value because it's very high up, even though it doesn't appear that way. Notice this is negative 5, this is 25, so obviously I compressed things a little bit. Okay, so ask questions as you need to, but I wanted to get through this quickly enough so that you kind of have a good look at what you got there.